Sir is pursuing his PhD in Electronics and Telecommunication Engineering and has 14 plus of years experience. His areas of specialization are Internet of Things and embedded control systems, robotics, automation, DS. Has presented 21 papers in national and international conferences and received many awards. Without wasting any time, I would like to hand over the session to the sir for the session on hands-on experience on HMI design using NI LabVIEW. To you, sir.
Thank you, ma'am. Okay, so first of all, I would like to thank you, Dr. Lochan Jolie, ma'am, XCOM member of IEEE Bombay section and the faculty of Thakur College of Engineering and Technology, for giving me opportunity to speak on HMI design using LabVIEW. Shweta ma'am, thanks a lot for introducing me. And I also would like to thank Sujata ma'am for close coordination from last almost 4 days with respect to software, with respect to guidelines. And also I'm thankful to all participants because they will be listening me for 2 sessions. The first session is HMI design using LabVIEW and second session is for Chrome. So the meaning of Chrome is the control, C for control, Rho for robotics, M for mechatronics, and E for embedded. Moving further, I just would like to give some of the overview of the today's session. I was listening also Dr. Arpit sir session, so there should not be overlap between 2 sessions. So I got the information. Dr. Lochan Jolie ma'am also took some of the session on the IoT interface using LabVIEW. But I'm little bit confused about the participant. So are they thoroughly aware about this platform, or should I start with the basic? That is my first question. So if you put in a chart, that will be great for me. So I will start with the basic and then I will take the some of the advanced application on LabVIEW with respect to Chrome. So I want take a more on this, the LabVIEW installation. I think already Dr. Lochan ma'am told you to install 2017. Currently there is a LabVIEW almost 21 version is available. So LabVIEW 21 is available, but fine. Lochan ma'am already instructed you to install the student version. So I'm having my professional version, licensed version. I just would like to highlight here very politely. There are many features will not be available at student version. So during that case, I think the session is recorded. So afterwards, you can utilize all those tools or the modules when you do the practice. Because student version having some of the limitations. All the models are not available in the student version, but in professional versions, all the models are available. So the today's is focus on the topic called the control and design simulation model, because our next session is simulation, the Chrome application module for the session. So with respect to it, this is the basic model we require while designing the control, robotics and mechatronics application. I believe that faculty members from different domain, from AI, data science, mechatronics, electronics and telecommunication, electronics, and maximum of faculty knows about the MATLAB. And that's why I will be also showing here the integration of the MATLAB with the LabVIEW. That is also one of the primary object of my first session. So installation is done. You know LabVIEW better because there are 2 sessions already you have done. One is Dr. Lochan Jolie ma'am and second is Dr. Arpit sir session. So this is the content for the 2 session where I will be taking the basic programming, but that is not that much basic. There are small things when you do the LabVIEW programming we have to understand. And then as control system, so we have to work on the differential equation. I will start with differential equation and then shift to the discrete simulation, and that day how to integrate the MATLAB with LabVIEW. I just also would like to highlight when we start the second session by probably 2:30. That time I will also introduce our lab at here in Patel, because we are the the Bosch Rexroth Center of Excellence Lab, where we have the complete setup of the pneumatic, hydraulics, PLC, sensoric, mechatronics. Also, we have the NI LabVIEW lab, and myself, I'm having both the certification. So I just show different components. Due to this virtual mode, it is not possible to do all the simulation. But yes, anytime you're welcome at Mukesh Patel to see the lab setup and look for all the integration what we have done at the Mukesh Patel. So I won't take more time, and I just start with the directly, interchange between this my PPT and the LabVIEW screen. So this is LabVIEW having different aspect. Like when I was looking for the Dr. Arpit sir session, he was typically focusing on the speech based application. So in LabVIEW, you can do the configuration, the textual map, simulation, state chart. Also, in LabVIEW, there are different versions available: Linux, the Mac based, and Windows based. There are also embedded platform. The very famous platform for the student perspective and the academia perspective is MyRio. So I will also show some of the simulation on MyRio controller, which is FPGA based. That's why I shown here this is embedded platform. These are the different hardwares. With respect to these hardwares, we can connect the LabVIEW. Starting with because we have the mechatronics department here, so we have some of the level control system where we can integrate. We have the PT100, USB 6.0, which is DAC card, Wi-Fi based DAC card, then TC01 thermocouple, then Zigbee module, the NOx sensor, vision based system. Also, we develop here the air heater system based simulation over here, and also you can integrate vision system also with the LabVIEW. So this is just a single PPT. I'm explaining what I will be covering. That already you know that the LabVIEW is the LabVIEW installation, which basically install the LabVIEW programming environment. We'll be focusing on the MathScript RT module because I said we'll be doing integration of the MathScript with the LabVIEW. So this module is specifically a tool which is very similar to the MATLAB and which is very beneficial to the all different domains of the participant. So this syntax is very much similar to the MATLAB. So you can create and you can run the end files. And this model is available from the tools menu inside that I will show you during my presentation. Then the next the model which I will be focusing called the control design and simulation model. So probably you have the student version. So in student version there are only two models are available in control and simulation, PID and fuzzy logic. Some versions are not available, and those versions are very much essential. I'm having those versions. So when you get the professional version at your end, so that time you please practice on that version. And the last is the NI DAC cards. So there are different DAC cards, the Wi-Fi base, USB base. Also with respect to DIDO and AIO, there are different DAC configurations. There are some shortcuts already. I was listening Dr. Arpit sir's session and he was saying the control T, the control E, control N for the new VI, control S for save VI, control V for the paste object, control Z for the last, control R for the run VI, display between block diagram and control panel, control E, control T is for tile block diagram and front panel windows, and control H for the display the context help. And also there is a tool palette. So I usually suggest the new learner of the LabVIEW, please put your tool palette on the automatic tool selection. So it automatically select the operating tool, positioning tool, leveling tool, wiring tool as per the design application. So this is basically the control and simulation in LabVIEW model. But can you just confirm at your end, because the version which you have installed on your desktop, probably you will be looking only two models, the PID and fuzzy. Can you confirm in the chart? or you have all these 5 modules, the PID, fuzzy, simulation, control, design, and system identification. Okay, I will just share my screen. So how to check? On a right click on the block diagram, and there's a control and simulation model. So can you check all the sub models are available? There are PID, fuzzy logic, simulation, control, design, and system identification. Please check and please update me in the chart. Control and simulation model, and these are the 5 sub models. Oh, PID and fuzzy only. Okay, thank you, Archana ma'am. Okay, so as I got the response from the participant, we'll start with the basic and move towards the advanced programming. So very simple, we'll start with the programming, the different types of programming we'll do, and we'll look after the case structure array, and then we'll develop the control applications. So very simple example I will take, which is everyone knows that I just double click on this and simple programming, write a program to convert from Fahrenheit to Celsius. That's it. So when you do this, the first we require the conversion formula. I believe the conversion formula is TF, temperature in Fahrenheit, is equal to 9/5 into temperature into Celsius plus 32. So I require basically inputs and outputs as per the control system language. So some of the basic probably you know, but again I'm repeating. Front panel, there are controls. You can observe there's a controls. And the block diagram, there are functions. So on controls, you will get the indicator and the control. So basically in LabVIEW language, the controls are input, simple inputs. So for this problem, our input is temperature in Celsius, and we are expecting the, okay, so if we are, so I will change here. If input is Celsius, so Celsius to Fahrenheit, Celsius to Fahrenheit. Okay. So input is here the temperature in Celsius, and the output I will take the indicator, which is temperature in Fahrenheit. So this is perfect now. So we are writing a program to convert from Celsius to Fahrenheit. Now once this is done, our input and output is ready. We require some of the mathematical blocks, like we require division block. We also require multiply block, and we also require the addition block. So 9/5. So how to create this 9/5? So just click on this division block. If you observe, when you click on this, there are 2 inputs and 1 is output. So click on that and just right click and create constant. Double click on this, replace by 9. Again, there's a second, create constant, and this is 5. Then 9/5 is multiply with TC. So, and it is with plus 32. So plus 32, so we'll be again creating the constant 32. And at the end, we get the output where we are converting temperature from Celsius to Fahrenheit. So how to run the button? There is an arrow. Just click it. So it is initially when temperature in Celsius is 0, Fahrenheit is 32. So you just increase it and run it. So it is 50. This is very simple program. I will take a same example and we'll do the different combinations. Once it is done, please update me by single message by any participant. Then I will go ahead with my next programming. Same program will enhance by different programming fundamentals of the LabVIEW. If it is done, can I proceed? Please reply in the chart. Yeah, thank you. So now if you observe, see many times when we develop the Chrome application, our topic is the Chrome, there is the next session. the control, robotics, mechatronics, and embedded application, we require real-time results. So for real-time, the system should be in a continuous mode. So now here, if you observe, when I'm putting the different, taking different readings, so like 9, I have to run, and then I will get the, I have to wait for the results. So if I want continuous readings, so specifically, I will use one loop called while loop, because every loop structure having some of the significance. So like for loop, we know that number of iteration, and while loop also we can use upon depending upon the iteration, and we have to stop depending upon the stop condition. So with respect to that, we can use the loop structure. So first we will use the while loop fundamentals. So how to use the while loop? Same program. In structure, there is a while loop. So this is the complete same conversion from Celsius to Fahrenheit in the while loop. But if you observe on the front panel, there is a broken arrow. So broken arrow indicates there is an error in the LabVIEW program. Why there is an error? Because LabVIEW doesn't know where to stop, when to stop. And if you observe, there is a stop button. Dr. Arpit sir also mentioned many times, and I would like to hear or mention very specifically, every programming having the data type concept. So we have the data type called integer, float, double, string, and LabVIEW recognize data type by the color. So if you observe the orange color, it is specifically for the float data type. If you observe the green, I will show where it is green. So I will here basically create control. So you can observe there is a green color. So this is called Boolean. So Boolean is indicated by green color in LabVIEW. And now there's a no broken arrow. And if I'm not wrong, I can run the program. So I'm getting continuous readings, continuous updated readings, right? And when I will press on the stop here, it gets stopped. So this is the significance of while loop. Okay, so I will proceed further. I will take a new VI, and here we'll see the execution of while loop. So just now we have seen the while loop. So I will take one while loop. Inside the while loop, in numeric, there's a random number. Once again, I'm showing inside a numeric, there's a random number. So random number creates the random numbers between 0 to 1. I will take one multiplication, multiplier. If you observe, click and press the Control H, it shows random number produced between 0 to 1. So we are writing the program to generate a random number between 0 to 10. So if I want that, then I will multiply by factor of 10. And here I will create right click. You have to do the right click, create indicator. Once again, I'm confirming that here, informing here that the control are input, indicators are output in LabVIEW. So there's a broken arrow. Why there's a broken arrow? The reason behind is what? We have to create control for the stop button, and I will run this. Why I specifically did this experiment? There's a reason. Can you observe? There are random generation is happening, which you can see very clearly on the front panel, but you cannot read it. The reason, because there's no delay. So how to add delay, that fundamental I want to teach here. So that's why I did this experiment. So how to add delay or the wait in the while loop. So what I will do, we'll stop, and there's a one more function in timing, wait millisecond. Once again, I'm showing that this is in timing, wait in millisecond. So when you add this wait timer, so what is the significance of this wait timer? It gives for every iteration, It gives good time to processor for other execution. So I just put it is in millisecond to wait. So I will create here constant, and which is I will write 1000 millisecond, which is almost 1 second. And now I will run this program, and you observe on the front panel. So after every 1 second, can you observe there is a random generation of number on the front panel. I hope this is clear to everyone, the significance of the wait timer in the while loop. Can I proceed further? Okay. So I will stop this. The next thing, I want to replace this while loop by the for loop. So right click on the while loop. You can observe there are different options. Replace with the for loop, replace with the time loop, remove while loop. So I will replace this with for loop. So the same program will perform using for loop. So there's a no stop condition in for loop. So I will remove this stop button. There's a broken arrow. So when you click on this control H, so you can observe there is a for loop help, where n is the value wired to the count n terminal, and the iteration I terminals provides the current loop iteration count, which ranges from 0 to n minus 1. So I just request all the participants that for this you to take the iteration as a 5, and please try to generate the 5 different values. If it is done, then what I will do with respect to this file for loop, I will add one more concept of the array. Now, how to take this array on the front panel? This is an array matrix. So I will just take array. Now this array is in control format. Okay. We have to make this as an indicator. So how to make as an indicator? Right click and change to indicator. So this is indicator. Okay. We will say, sir, what is the significance of array this with for loop, for loop or while loop? Yeah. So when you want to store number of values, okay, for the further processing, will store in array. But how will you do that? So this is the control indicator. I will simply put this control indicator in the array. Can you observe this? I hope this is visible properly. Can you just confirm it is visible? Yeah. So what I'm doing, I'm selecting this, I'm putting inside this array. Okay. So just observe the change. Once again, I'm doing the undo. If you observe, this array is also in black on a block diagram. But as soon as I'm putting inside the array, it is converted to float. I just connect this to here, to the for loop. And this is called auto index tunnel. And I will connect to the array. Right? On this array, when you select this array, you can expand this array. How to expand? Take the cursor on the array. There is a symbol of array you can observe on the bottom corner. When you see that symbol, just expand it. You can expand row wise or you can expand column wise. And this is called indexing in the array. So there's a broken arrow. It is showing the error still in this for loop. So error is the n is not wire, or there are no indexing input. The counts, they require the count. So what I will do, I will create constant. I will write 5, only 5. And now this program is perfect, and just we'll see what is happening. So I have given n equal to 5, and that's why you can observe there are 5 values are stored in the array. Instead of 5, if I do 8 and if I run, there's a delay of 1 second. Yes, you can observe the 8 values in the array. I hope you have completed this. Can I proceed? Yes, thank you. So this is, we started with the while loop. We added the delay timer, the wait timer, then for replace while loop by for loop, then we add it with array. So I also explain how to, add indicator in array. So I just want to show one more thing here. I will take one more array here. In array, you can put any data type. Now, what is the mean of any data type? I will take the LED. I just select this LED. I can also put LED also in array. So you can also take a different possible combinations of the Boolean array data. Okay. So this is the specialty of the lab. Okay. So this is done. So we'll understand one more concept, because all these fundamentals we require when we develop the any robotics and the Chrome based application, because in robotics application there are different cases are available. So how to use cases, the case structure in LabVIEW, that I will teach you. So this is one random generation. There's a one more program what we were doing earlier. So same program I will take, convert from Celsius to Fahrenheit, and that we did using the while loop. I will remove while loop now, and we'll understand how to use case structure in LabVIEW. So for case structure, in structure, there is a concept called case structure. So when you can observe in case structure, there is a true and false. So same program will develop using case structure. So when case is true, it will give the correct conversion from Celsius to Fahrenheit. But when case is false, it throw the wrong output. How can we develop this case structure using LabVIEW? That we'll see. Just take instead of thermometer, I will take and this is my temperature in Celsius. I will remove this now. I also require one more for TF. One is Celsius, one is Fahrenheit. So output is Fahrenheit and input is Celsius. Input temperature is Celsius, and input is always control. So I told you, I explained you earlier. Right click and change to control, and output is indicator. So when case is true, it should convert correctly. So this is the basic. So this is the actual logic of conversion formula. So I will take this inside the case structure. So we'll connect to this, and this is connected to this logic. Again, this side, and this is connected to the output. So once this is done, still there's a broken arrow. The reason behind is you would also write the logic for the false side. So the case, just now you wrote the logic for the true side, the true case. Now we'll write the logic for the false case. So the false case, it will show the wrong temperature. So what I will create here, I will create the 50. So when there's a false, it will show always 50 Fahrenheit. Okay. But still it is showing the broken arrow. Reason, the term is missing here called selector tool. How will you select the case? How will you select the true case? How will you select the false case? So for that we require case selector. So if you observe, there is a green question mark, that is called case selector in lab. So it is green color. By default, earlier I mentioned it is the Boolean data. So I just create control. So better I will create one switch here. I will take Boolean, so I will take here switch, vertical toggle switch here. Okay. So this is the case selector. Okay. So now this is running perfectly. So I think it is false case. That's why it is showing the 50 if I'm not wrong. And when I will change to toggle switch, it is showing the correct conversion, 32. Perfect. But when I make this toggle switch here, the false case, it will show the 50. I hope this is also clear to everyone. Okay, so if this is done, then the next thing which I would like to show, if you want this program in a continuous, as I mentioned earlier, for continuous mode, the best loop is the while loop. So I will use while loop, create the control, and I will run continuously. So with respect to the false state, it always gives the 50. You can observe there's no change. But as soon as I will change the toggle switch to the true case, it is showing the true conversion from Celsius to Fahrenheit. Okay, so now again, just now what I talked, that is about the simple Boolean application. When there's a discrete digital application, on-off case. But in industrial automation, there are a number of cases you usually observe on the plant. And with respect to different cases, probably there are n number of cases. So how will you make the case structure if there are 4 or 5 cases? I believe that is not possible with respect to this Boolean case selector. So if there are only 2 cases, you go with the Boolean selector. But if there are more than 2 cases, yes, that feature is also available in case structure. So how will you develop that? I will show that. So there's an option, right click on this, and there's an option called add case before or add case after. So I will write here add case after. So you can observe there are 3 cases, false, true, right? You can also make this as a, this is as a 2. This true you can make as a 1. This make as a 0. So there are 3 cases you can observe. For 1, you get a correct conversion from Celsius to Fahrenheit. For 1, you get a correct conversion. For 2, you get the reading always 50. And for 0 also will connect Celsius to Fahrenheit directly. So whatever Celsius, so you can observe for 0, you're getting the same Celsius as a Celsius. For second, you are getting the false temperature as a 50. And for first case, you are getting the correct conversion from Celsius to Fahrenheit. But still there is a broken arrow. The reason behind that, the earlier case was the Boolean, where 2 cases we were looking, but now the cases are more. So the Boolean case selector is not useful. Still it is showing the green. But when I will do the right click and create control, it is still doing the Boolean. The reason behind that, there are small logics in the LabVIEW. What the logic that I will explain you. Okay. So there are a number of cases. I will take here the control first. So see, this I would like to highlight here. Why it was not happening? Because that was a Boolean case selector. So I just would like to highlight here. I will remove here and do everything. So there are small things in the LabVIEW. Okay. So observe here, there is a green color, which is Boolean case selector. But as soon as I took the control, the float control, and when I'm connecting this, you can observe it will automatically convert to the blue one. The blue is integer. And automatically earlier it was showing 0 with double colon, but now it is showing the 0. Now this is perfect. So my 0 case gives the correct output. So this I will connect to now this indexing and this. Okay. So this is zero state. Now I have to add one more state, which is add case after. So which is one state. It will give the output as a 50. So create constant 50. And the last case, there are many cases you can do. So add case after second case, which it will show the same Celsius temperature. Okay. So now still there is a broken arrow. Can you observe there is a broken arrow? We did everything properly now, but still there is a broken arrow. The reason, yes, no case for some selector values. So we'll see once again. For 0, it is connected. For 1, it's proper. For second is also perfect. So now I'll connect this. Okay. So okay. So right click. Just observe whether it is connected properly or not, because sometimes it gives the error. So this is connected. Okay, when you come on a 0, there's a one more thing we have to do, that make this as a default case. So now you can observe, when you make this default case, your broken arrow get vanish. These are the very small things in a LabVIEW that we should know. Otherwise, you cannot make the good application. So now it is perfectly working. Once again, I'm repeating, for case structure, when you require the more than 2 cases, so the first you select the numeric control. When you connect the numeric control to the case selector, it will automatically change to the integer, and then you add 0, 1 up to the cases which you require, and the 0 case you have to make as a default. So that time your program get run. So when I will run this, so the for 0, it is showing the correct conversion. When I will make, sorry, not 1, it is showing the 50. When I'm making the 2, it is showing the same temperature. I hope this is also clear to everyone. Can I proceed further? Okay. So we'll proceed further. The next fundamentals. I will take a new screen where I will explain the fundamentals of different data types. So this is numeric control, and this is numeric indicator. If you observe, the color is the orange. So this is flow data type. Same numeric control in representation. If I go to the integer, I will take one more indicator here, and I will change the representation as a integer. The data type is indicated by integer is view. I will take the string command. I will take a string control. Also, I will take a string indicator. So string and string data type is given by the, you can observe by the color purple. I will take the boolean. . and I will take the indicator. So you can observe it is shown by the green color. So this is data representation in LabVIEW. So I just want to express here in LabVIEW, you can connect same data types. But if you try to connect the integer with string, it won't connect. String with boolean, not possible. And any other combination. So that's why I did this basic of the data type. So you can connect the same data type with other same data type. Okay. But there's also provision in a LabVIEW where you can club different data types together with one fundamental called cluster. So that programming we'll see now. I have shown here very clearly that integer cannot be connected to string and the string to the boolean, right? So we'll understand the fundamentals of cluster. Because in industrial automation application or robotics or mechatronics application, we have to do the cluster programming where different types of data types we have to use in that applications. So how to use cluster programming in array matrix and cluster? There is a cluster. Just take a cluster. So what we will do, we will same fundamentals. I will explain the data type fundamental with one program. So we'll make one application where we are taking the input from the user. So taking the input from the user, I require the string control. So where I will be taking the first name. Second, for I will take the last name. So these are the string data type indicated by purple color. I will take numeric control for age, and for gender I will take the boolean logic 0 and 1. So there are different data types. Just now I explained that different data types you can club together here with the help of cluster. So for we'll remove cluster first. So for this first name, I will create the indicator here. Sorry, wait. This is changed to control, and I will create indicator. For last name, I will again create here the indicator. Create to indicator. And create to indicator. So in one simple program, there are different data types we are using. So how will you make this? So how will you use this cluster? Very simple. Now take the cluster where you are putting all different data types together. You are selecting this way and you are putting in this cluster. Can you observe participants on the right side of the block diagram? The all different data types I have clubbed in the cluster. So this cluster having different data types, and this is the plot which is created on the block diagram. I will take a first name here. This is second name, and this is a gender. Okay. So now, suppose if you are putting the first name is D, last name is S, and for, and but how to understand the gender, right? This is, so what we will do, there is a one option that called, the concept called Boolean text. So you can observe when you are creating that Boolean text, so this of, you can write as a gender as a female, and when you just, this is, there's a on, where you can write as a male. So when you run this, probably you won't get any output on the first name, last name, to age 2 and the gender 2. The reason, the all different data types are clubbing cluster. So you have to the bundle it or unbundle it. Okay. So there's a what is called this bundle and unbundle that I will explain. Again, on a block diagram, there's a cluster. So there's an option called bundle. If you observe this option of bundle, now this bundle by name doesn't know how many data types are available in this cluster. But as soon as you connect this cluster to this bundle, wait, this is, I think, you have to take unbundle from this unbundle in cluster, there is a unbundle. So you can observe now it is not recognized how many different data types available in cluster. So I will take from here, connect to the cluster. As soon as it is connected, that unbundle functions recognize that first two are string data type, third one is the float, and fourth one is boolean. Now from this unbundle, you can connect to this. And when you run this, you can observe the output on the first name to, last name to, age to, and gender. I hope the cluster fundamental is also clear to everyone. Done? Participant, please reply so that I can proceed further.
Done, sir.
Yeah, thank you. So the next and the last topic which I would like to cover here, that is the many times participant won't understand or the new learner in the LabVIEW, they will understand the difference between the waveform graph and the waveform chart. So what for that, what we will do, we will take the close this. I will take a new VI. And there are two graphs. One is waveform chart. and there is a waveform graph. So we'll understand the difference between waveform chart and graph, because when you look for the any application, when we are looking for the results, what's the difference between chart and graph, that we will see first. So in mathematics, in elementary signal, there's a sign, and you can observe control H, which is compute sine of x, and where x is in radians. We'll create a structure and we'll take one while loop. Create control. I just try to run it and we'll see the output, basic output, what it's showing. There's no output. There's a reason behind that. Just show that also. So if I try to connect this waveform graph over here, it won't connect it. Now I will take this outside. I will remove this. I will try to take chart over here. Try to connect inside this. So it is showing some of the output, but not clear. So what I will do, I will add the delay wait state. Create a constant of 1 millisecond, and let's see if there's any change or not. Okay. Let's try to change the so yes, I can see some graph. I just change the time to 100 milliseconds. So probably process more fast. Okay, it's perfect. Great. Okay. I want varying change. So instead of this indicator, I will take the knob. That is the best combination. Okay, and I will run it. I hope the readings are very much visible to everyone, right? Now topic, the what's the difference that I will explain. Probably that is the conclusion of this legislation. And I will take the last part, that is I will take here graph. Which I connect here. Okay, so if you observe, this is not connecting. But if as soon as if I replace with a shift register, still it won't connect. So place with tunnel. So what I did, these are the small things which I would like to explain here my participant. In tunnel mode, there is a called indexing. So when I did indexing, if I'm putting a last value, see it is showing the error. But when I'm making the tunnel mode as a indexing, it is perfectly get connected, right? And now I will run it. Now my participant tell me the difference between the waveform chart and waveform graph in LabVIEW. So I will start. So I'm making the changes, but I can't see when there's in a running stage, I can't see any change. But as soon as I stop, due to indexing, the data is stored and which you can observe on the graph. This is the difference between chart and graph. I hope this is clear to everyone. Any doubt for this program? In this tunnel, in tunnel mode, you have to make the indexing. Then only you can connect the graph and the chart you can inside because that is the running status. But in graph, it stores and then it will shows the result. So this is the difference between waveform chart and graph. So I conclude for this my session 1. I started all the different types of case, array, the cluster fundamentals, also the waveform chart, waveform graph. So during session 2, first I will show all the setups which we have here for 5-10 minutes, and then we will do the control and simulation based application, and we'll integrate the MATLAB with the LabVIEW. I understand due to student version, there are some functions are not available at your end, but this session is recorded. So whenever you get a professional version of LabVIEW, that time you can practice. Thank you once again for listening me for last 1 hour 30 minutes. Thank you.
Thanks a lot, sir. And we'll be waiting to listen to you once more in the next session.